Okay, I'm going to do sections 2.1 and 2.2 together because they just naturally flow with each other. So what I mean by that is once we do a frequency table, we get a histogram for free. So we're starting to learn to make graphs because we want to organize and summarize our data. You'll see when I do an example what I mean by that. You may have made one of these before, where we're going to have classes, and then we're just going to show the number or frequency of the data values that lie in each of the classes. Here's some definitions that you'll want to learn. I'm not going to read them to you. You can read about them. I'll mention them probably when I'm building one, so you'll learn as we go. More of the same. Okay, there's a recipe in the book that is just kind of an outline. You don't follow it exactly. But I'm going to use this to calculate my class width because I'm going to make 5 classes. And you pick these. And it could, they say between 5 and 20. Yeah, I don't know if I've ever done one with 20, but that's if you have a big spread in the data. So I usually start with 5, and if I need more, maybe I'll jump to 8 or something. But I usually don't go less because then your data gets too constricted and you lose the story you're trying to tell. Okay, so here's what I mean about organizing. Here is a table of data where it's really hard to see what's going on. I can't tell you what any, I guess, patterns I may see in the data. So we're going to organize it better. And you weren't supposed to see that yet. So, okay, there we go. Okay, so I'm going to use the recipe. I'm going to do 5 classes. So I'm going to find the class width. Which is the high value, subtract the low, and in this case, divided by 5, my number of classes. Oh, and I wish I would have done this beforehand now. So let's find the highest value there, it's 308. Now let's find the lowest value. Okay, I see a 90, I see an 83. That looks to be it. So with these drive-through times, this is in seconds. Let's see what I get for a class width. $45. So let me write that down up here. Okay, so I'm going to start to build a frequency table. So I'm going to start with the lowest data point, which in this case was 83. And now my next class is going to be 45 more than this, which is 128. So my first class will be 83 to 127. So I'm just going to keep adding 45 to my lower class boundaries. Then I'll find my upper class boundaries. This becomes 173, so this goes to 172. This becomes 218. Notice how I'm just getting these to be one less. $262. And then I add 44. So notice in between all of these is my class width. No matter how I check, it's 45. So I have my classes. So what I do is I'll just go through and start doing tally marks. But then over here is my frequency because I actually want a number and not just tally marks. So I need to see my data. So like 107, that fits in here. 139, that fits in here. 197 in here. 209. So I'm just going through all of them, just putting them in there. And then I would get all my tally marks, and then I would just count them and get my frequency. Now I'm going to stop because I'm not going to fill this out. Because here's why. Let me erase this. Look at these classes that I created. These are really ugly numbers. Yeah, they're going to work almost. If you notice, my highest was 308. I didn't capture 308. It would not be in here. So right there, they're bad numbers, but they're not pleasing to the eye. So when I say that the procedure is just a beginning, let's clean these up. You know what's more pleasing is a class width of 50. And instead of starting at 83, I'm going to start at 75 because look how fast I can write these down because we're really used to going up by 50s. These look much nicer. Remember, we're trying to tell a story with this. And also notice by doing this and making my class width a little larger, my data value of 308 is captured in this one. So I won't bore you with making it, but here it is. Notice these classes look a lot nicer. I can see the frequency in them. I can talk about the shape of the frequency. Starts a little bit, grows big, then it comes down. If I turn this, it doesn't look normal or symmetric. This is an example of skewed right, where we have these values out in the right end of our values. Now I'm going to add a quick column here, the relative frequency, where I just take each one of these and I divide by n. We have 50 of them. So 11 divided by 50, for instance, is 0.22. You can give it that way, or if you want, you could put in the percent. That's okay. So this is 0.48, 0.20, 0.06, 0.02. I tend to go with the decimal values because we can relate relative frequency to probability in chapter 4. Okay, so we built a frequency table. Now I'm going to construct a histogram because, like I said, I get that pretty much for free. So I'm going to do that here. Okay, so this is wait time. At the takeout window, the units are seconds. Notice how I labeled those. Over here is frequency. I'm labeling that. I did not give myself enough room down here. I'll go smaller. Okay, now my frequency, notice that I have 24 I have to capture, so I'm going to scale this by tens. Now, we have no gaps. All I'm going to do is I'm going to start at my lower class limit of 75. Notice we don't have 0 because we're starting our classes at 75. Then I'm going to go up to 125. I'm just going to use those lower class limits. And this would be 325. So my class width is 50. Maybe I will change some color here. So between 75 and 124, we have 11. The next one, we have 24. And I'm down to 10, 3, and 2. Now, if you look in, and when you read the Triola book, he will not make the classes like this. He'll do something different. He'll use the class midpoints. He would do in his histogram, I'll show it up here, he would do 74.5 to 124.5. That would be instead of the 75 and the 125. He does that because if you have a data value of 125, we know it falls to the right. Almost said it fell in there. I have some ambiguity here because if I have a data point of 125, I don't know if it's in this one to the left or this one to the right. So I add a legend. Data falls to right. I think this looks cleaner. And now if I have, say, a data point of 275, I know it lies in that class and not that one. Let's finish this up. Just a couple things. Here's a frequency table with weights of randomly selected pennies. I can zoom in, I guess. Notice we have a gap in here. Well, that's because prior to, I can't remember the date, somewhere in the 60s, pennies were made with copper. Then they were made with zinc because copper was too expensive. Copper and zinc weigh differently. So if you can look at your periodic table of elements and tell me which of these is heavier, I would know that these are the heavier ones. Someday I'll look that up. I'll rely on you people that are in chemistry. So gaps can tell us if there's something going on, maybe two populations. which happened here. So we had two different populations of pennies. So that's one thing that a frequency table can give us quickly, is to get an easy way to look at that. Our data is well organized. Oh, 1983, there we go. Notice they didn't tell me which one was heavier either. So that's it for this section.